Welcome to the training course on IBM Scalable Architecture for Financial Reporting, or SAFR. This is Module 12, the Single Pass Architecture. Upon completion of this module, you should be able to describe the single pass architecture, read an extract-only logic table in Trece, explain the function codes used in the example, debug and or selection logic. The prior modules covered the function codes highlighted in blue. Those to be covered in this module are highlighted in yellow. One of the most powerful features of SAFR is the single pass architecture. Input-output processing, or I/O, is often the slowest part of data processing, at times thousands of times slower than other functions. SAFR's single pass architecture allows for a single read of the input data to produce many different outputs. Each output can be unique, as specified by the individual views. In this module, we will continue to build on the prior lesson, where a copy-only view was processed alone. In this module, we will add an extract-only view. Both of these views do not require the reference or format phases of the SAFR performance engine. In this example, we'll also execute the copy view at the same time as the extract-only view, demonstrating how SAFR's single-pass architecture works. The logic table will contain two views in one logic table. The extract engine, GenevaERS, will produce two outputs. Instead of copying all the fields on the input records to the output files, the extract-only view writes selected fields to the output file. Any fields may be written to the extract file in any order, regardless of the order or position on the input file. Field formats may also be changed, for example, changing a zone decimal to a packed field format. These columns will cause DTE logic table functions to be generated in the logic table. Constants can also be written to the output file. Constants use DTC functions in the logic table. Extract-only views can also contain looked-up fields, which will be explained in the next module, and which generate DTL logic table function codes. In our example, columns 1, 2, 3, and 5 of the view will contain cost center, legal entity, and the account fields, and a record count, respectively. Logic text in column 4 will cause the output file to contain a constant of either the value asset account or liability account. Asset ACCT will be assigned if the account number field on the input file contains the value 111, 121, or 123. Otherwise, column 4 will contain the liability account constant, which is the value LIAB-ACCT. This logic text will create multiple CFEC functions introduced in the prior module. Column 6 contains logic text that tests the input amount field. If the amount is a valid number, is numeric, it will be written to the output file. If the amount on the input file is not numeric, a constant of 0 will be written to the output file. This logic will generate a CNE function in the logic table. This is the logic table generated for both the copy view and the extract-only view. The portions of the logic table generated for the copy-only view example in the last module remain mostly unchanged. It includes the HD header, RENX readNext, and the logic table rows 3, 4, and 5. The last two rows of the logic table, the ES end of source, sometimes called the end of string, and the EN end of logic table functions, are very similar as well. Only the row numbers on these last two rows have changed. Our new extract-only view, number 3262, is inserted in the middle of the logic table. So each record read from the input file will first be passed through all of the logic table functions for the copy-only view, and then through the logic table functions of our new extract-only view. Our extract-only view again includes an NV, new view function, and concludes with a WR function. In this case, instead of a WRIN function, which writes the input record, makes a copy of the input record, it is a WRDT function, which writes the data area of the extracted record. Columns 1, 2, 3, and 5 simply move fields from the input file to the output file. These columns cause DTE functions to be generated in the logic table. The DTE function simply moves data. The DT is derived from data. The E means the source is the input event file field. Each DTE function is followed by a sequence number. The sequence number for each DTE shows the column number causing that logic to be generated. Each DTE row also contains the position and length in the source event file. These positions, lengths, formats, and numbers of decimal places are taken from the logical record describing the input file. Each DTE row also contains the length and format to be placed in the output file. A difference between the length, format, or number of decimals between the source and target columns indicates CFEC has performed a transformation before writing that field. In this example, no transformations occurred. The report does not show the position in the output file. The start positions in the final output file is shown in the view editor of the workbench, but the final output file position may be different than the extract file position, depending upon the view type. The extract file position can be calculated by accumulating the lengths of all preceding column outputs. The first part of the logic text in column 4 contains the text if account equals 111 or account equals 121 or account equals 123. This causes multiple CFEC functions, compare field from the event file to a constant, to be generated in the logic table. The CFEC functions in the logic table rows 10, 11, and 12 are generated by this specific if statement. The sequence number field of the report shows the column number that contains the logic that created the CFEC. In this instance, the logic is contained in column 4 of the view. CFEC functions work together to complete a complex or AND test. In this example, the OR statements caused 3 CFEC functions to be created. The first test for account equal to 111 is performed on logic table row 10. The second test for account equal to 121 on logic table row 11. And the third test for account equal to 123 on row 12. Because each CFEC tests the account field, the E or event file field position of CFEC, the position, length, and format of the account field is shown on the source attribute columns. Because the account is used 3 times in logic text, the same position, length, and format are used on all 3 CFEC rows. The constants, the second C of the CFEC, are also placed in the logic table. These 3 constants are placed at the end of their respective logic table rows. These 3 constants all are a comparison type of 001, which is equal, and are all 3 bytes long. The OR condition of the logic text determines the numbers placed in the goto rows. If the value in the account field on the input file is 111, then the result of the first test is true, and the record should be selected for additional processing within the column. Thus, executing will jump to row 13, as specified in goto row 1, which is the true condition branch. If the logic table row tests false, then the other test of the OR conditions must be evaluated, including testing for values 121 or 123. Thus, the false goto row is row 11, the next logic table row, where the next CFEC function will test against a constant of 121 rather than 111. The second OR condition creates a similar pattern on the next CFEC function, testing against constant 121 on logic table row 11. If true, then the next row to be executed is row 13, where the column will use the input record in some way. If the value is not 121, Then the next row executed is row 12, the next OR condition, to test against value of 1, 2, 3. Row 12 tests the account field on the input event file for value 1, 2, 3. If it tests true, then the next row to be executed is again row 13, which will move a constant to the output record. If the value is not 1, 2, 3, then the next row executed is row 15, which means the else condition for the column value will be used. The then and else portions of the logic text cause additional rows to be generated in the logic table. If a field was moved from the input file to the output file, they would be DTE functions, like those generated for columns 1 and 2 and others. In this example, constants are to be moved to the output record, so DTC functions are generated, DTC meaning data from a constant. Logic table rows 13 and 15 are both DTC functions. Row 13 places the constant for asset account in the output file if any of the CFEC functions tested true. Only if the count field on the input file has the value of 111 or 121 or 123 will the output column receive the value of asset ACCT in it. On the other hand, row 15 places a value for liability accounts. It is executed if all CFEC tests are false. Thus, any account value besides those 3 tested will result in the value of liability account in column 4 of the output file. If all the rows of the logic table were executed sequentially in order without skipping any rows, the constant of liability account would overwrite any asset account constant placed in the output record. To prevent this, a goTo row is used to skip the DTC for liability account whenever an asset account is used. In our example, row 14 is the goTo row. If row 13 places asset account value in the output file, the program naturally falls through to row 14. The logic table then tells the program to jump to row 16, skipping row 15. This prevents the value of asset account from being overwritten with the liability account constant. With OR logic, all 3 CFEC rows execute row 13, which places the asset account value in the output. If any one of the rows is true, asset account is placed in the output. If our logic text were changed, and we used AND logic to test 3 different fields, our goTo row 1 and 2 would be swapped. AND conditions require that all 3 rows test true. The effect is that true and false row numbers switch places for AND versus OR logic. With AND logic, a true condition on each CFEC causes the logic to continue to the next row of the logic table to continue the test. After the final test of the AND condition, if all tests have proven true, the DTC function on the logic table row 13 is executed to build the asset account constant. If any of the CFEC functions prove untrue, execution continues at logic table row 15, the liability account DTC function. A common debugging problem occurs if logic text requires the same field to contain multiple values by using AND when OR was intended. The same field on a single input record can never contain multiple values. For example, the field account can never be equal to 111 and 121. The condition would always prove false. Using the logic table to read how the logic is interpreted can uncover these types of problems. The last column of the view tests to ensure only valid numeric values are placed in the output file using the logic function isNumeric. The isNumeric function in column 6 of the view generates a CNE function, a class numeric test of an input event file field. The CNE function is similar to a CFEC function. It tests a value and directs execution to the goTo 1 or 2 rows depending on the results of the test. The CNE function on row 17 in our example tests if the input field amount contains a valid numeric value. If so, row 18 is executed. If the input field is not numeric, go to row 2 will cause row 20 to be executed. The then and else condition of a logic text for column 6 performs different functions. The then condition causes a field from the input file to be moved to the output file. The else condition causes a constant of 0 to be placed in the output file. The true test of the then condition of the CNE test on row 17 will execute row 18, a DTE function, moving the amount from the input record to the output. The false else condition on non-numeric causes row 20 to be executed, a DTC function, placing a constant of 0 in the output file. The final instruction of the extract-only view is the WRDT function. This function is generated by default at the end of a view if there is no write logic text function in the view. In these cases, it is always executed. In contrast to the WRIN function, which moves the input record to the output file, the WRDT function moves data from the extract record area to the output file. All of the data moved to the extract record through the DT functions, both DTCs or DTEs, are actually written to the output file. The WRDT is followed by a sequence number 1, meaning it writes its data to file number 1. This is the same file the WRIN function of the copy view uses. Thus, after the first input record is processed, the first record in the output file may be the copy of the input record selected by the copy view, followed by the extract-only data of the second view. Having examined the logic table, let's use our 3-record file again to see how it behaves through the trace process. Trace is turned on by setting the trace parameter to y in the MR95 parameter file. The first 3 rows of the trace are for view 3261, our copy view from the last module. The first input record is compared against the constant in the CFEC function. The comparison is true, and so the next row of the logic table is executed. Because the test proved true, the input record is copied to the output file by the WRIN function. Because our safer execution included running more than one view, instead of looping to the next event file record and the copy input view processing it, the input record is passed to our new extract-only view, number 3262. Note that some rows of the logic table are not executed as record 1 is processed in this example. Rows 11 and 12 are not executed because the OR condition in the logic text, the first condition proved true, so tests 2 and 3 were not necessary. Also, row 15, which would have placed the liability account in the output file, was skipped by the goTo function on row 14. Row 20 was also skipped because the amount was a valid number, so it was not replaced by a constant of 0. Note that the trace does not convert packed or other unprintable data in a printable format. The number tested on row 17 appears to be printed as a P, but if viewed in hex mode, will display a valid packed numeric field based upon the format of the field used in the numeric test. The single-pass architecture allowed the same record to be used to create 2 output records, one which was an identical copy and one which contained selected fields and constants. The second record in the output file contains many of the same fields as the input, but in a different order, for the cost center and legal entity, each built by the DTE function. The account value of 111 is written to the same position as in the input record by the DTE function. The account description is next, in this case asset account, built by a DTC function. Having tested the amount on the input file and found it to be numeric, the view copies it in the last position of the output file using a DTE function. Both views are able to make use of the same input record without having to read the file twice. Making changes to the view, these output records could also have been written to different output files if desired. Record 2 follows a similar pattern. Record 2 is processed first by the copy view, which writes it to the extract file. Record 2 is then passed to the extract-only view. Note that the amount field on the input record 2 has a non-numeric amount of alpha in it. This causes the extract-only CNE test to prove false, and thus this value is not moved to the output record. Rather, a packed constant of 0 is moved to the output file, which is unprintable in this slide and shows as a series of periods. Record 3 is read, which then is not selected by the copy-only view because the legal entity tests false. The legal entity is 731, not the 999 required. Thus, this record is not written to the extract file, and the input record is passed to the extract-only view. When record 3 is processed by the extract-only view, it is written to the output file. The GenevaERS control report shows that the 3 records in the input file have become 5 records in the output file, 2 for the copy-only view and 3 for the extract-only view. The extract engine in this process has significantly increased efficiency over alternative methods of producing these 2 outputs, because in a single pass of the file, one I/O to get to the event records into memory for processing has allowed both outputs to be done. Certainly programs can be written to do the same thing, but it demands a programmer writing the program to design it that way. With CFEC, 2 people independently can create views, and the tool will resolve them efficiently. Remember, though, that this process does not include any parallelism. View number 2 is executed after view number 1 has seen the event record. We'll explain parallelism in a later module. The logic table and module has introduced the following logic table function codes. CNE, a class test numeric on an event file field. DTE, which moves an input field to the output buffer. DTC, which moves a constant from the logic table to the output buffer. WRDT, which writes the DT area to the extract file. This module described the single-pass architecture and additional logic table processing used by the extract-only view. Now that you have completed this module, you should be able to describe the single-pass architecture, read an extract-only logic table and trace, explain the function codes used in the examples, debug and or selection logic. Additional information about CFEC is available at the web addresses shown here. This concludes Module 12, the single-pass architecture.